Hi everybody. So in this question, we're told that an engineer is investigating the motion of a sprung diving board at a swimming pool, and let E be the position of the end of a diving board when it is at rest in its equilibrium position, and when there is no diver standing on a diving board. We're told that a diver jumps from the diving board, and the vertical displacement h, the end of a diving board above E, is modeled by this differential equation, where T is in seconds is the time after a diver jumps. We would have to work out a general solution of a differential equation. So we're going to use an auxiliary equation where we get a 4m squared plus 4m plus a 37. So I've just taken the coefficients from here, and this equals 0. So now we can solve this equation, and we get m is equal to -1 plus or minus 6i over 2. So our general equation then will be h is equal to e to the power of this real part, so negative 0.5t, multiplied by a cos to the 3t, which is this imaginary part, plus b sine 3t. And this is our general equation. For part b, when t equals 0, the end of a diving board is 20 centimeters below e and is moving upwards with a speed of 55 centimeters per second. So this speed is also dh by dt, the rate of change of height with respect to time. Find, according to the model, the maximum vertical displacement of the end of a diving board above E. So if I make a note then, when t equals 0, h will be -20 and dh by dt will be 55. So now we can substitute these two into our general equation. So h is -20, and we've replaced the t with 0. E to the 0 is 1, and the cos of 0 is 1, so this will leave us with a, and the sine of 0 is 0, so a will equal -20. So I'll substitute this back into h, and then we need to differentiate this with respect to t, because we know dh by dt is 55, and this will help us find the b term. So I'm going to use the product rule to differentiate this. So we've let u equal this term, differentiate that to get u prime, v is this term, and differentiate that to get v prime. So now we can work out dh by dt. So this will be u multiplied by v prime minus the v times u prime. Now we can substitute in t equals 0 and dh by dt is 55. We know e to the 0 is 1, sine of 0 is 0, cos of 0 is 1, so we can simplify all of this. So 55 is equal to 3b minus 1/2 of -20. So 3b will equal 45, b will equal 15. So I'll substitute this value back into here. Okay, so now we've got an equation for h. If we go back to our question, we wanted to find, according to a model, the maximum vertical displacement of the end of a diving board above E. So if we want a maximum of h, we can find dh by dt and set it equal to 0. And you can see that we did most of this here. So if I replace this b with a 15 and tidy this up, we'll set it equal to 0, and then we'll solve the equation for t. So the first thing we'll do to tidy this up is we'll expand out the brackets. Okay, so at this point, we've expanded the brackets, and I'm going to factor out this e to the negative 0.5t. And from this point, we'll collect the sine terms together, and we'll collect the cos terms together. And we know that dh by dt is 0. So we'll get rid of this, and we'll replace it with 0. Now we know that this can never be equal to 0, so this must be where our solution is. And if we divide both sides by cos of 3t, then we'll get sine over cos, which is tan. Now we can move this 55 to the left-hand side and divide both by 52.5. So the tan of 3t will be negative 55 over 52.5. We'll take the arctan of both sides, so therefore 3t will equal negative 0.809. But this gives us a negative time, so we can work out the other solution using the CAS diagram. So the value of t that we want will be in this angle here, and this will be pi minus 0.809, which gives us 2.33 radians. So we're saying that 3t will equal 2.33, divide both by 3, so t will equal 0.778 seconds. If we go back to the question, now we have our value of t, we can substitute that into h to find the maximum vertical displacement. So we've got the equation for h, we'll substitute in this to t, and we'll get h is 16.71 centimeters. Okay? And then for part C, comment on the suitability of a model for large values of t. We'll say that the large values of t, e to the negative 0.5t becomes very small, which reduces the oscillation. Therefore, the model is suitable. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, you can find lessons on this topic from my website, mrmathematics.com. I'll leave a link in the description below.